Welcome to Daily Papers, the podcast where we break down fascinating new research into plain English. Today, we're looking at something straight out of a spy novel, but for the digital age.
Imagine you want to send a secret message. Not with invisible ink, not with a complex code, but by hiding it in plain sight, inside another message that looks completely normal.
Exactly. For example, what if you could write a tweet that fiercely criticizes a political leader, but hide it inside a tweet that looks like it's praising that exact same leader?
Or you could hide the first chapter of a secret, unreleased novel inside a bland review for a new video game. The two texts would be the same length, and both would read perfectly plausibly. To the naked eye, you'd never know one was hidden inside the other.
This sounds like science fiction, but according to a new paper from researchers at the University of Oxford titled LLMs Can Hide Text in Other Texts of the Same Length, it's now a reality.
And it's all thanks to the technology behind tools like ChatGPT, large language models, or LLMs.
So before we get into how this works, let's define a key term: steganography. It's a bit different from cryptography.
Right. Cryptography is like locking your message in a super strong safe. Everyone can see the safe, but they can't open it without the key. Steganography is different. It's about hiding the safe itself. The goal is that no one even knows there's a secret message to begin with.
A classic example would be writing an acrostic poem, where the first letter of each line spells out a secret word. The poem is the cover text, and the secret word is the hidden message. This new paper presents a wildly more advanced version of that idea.
So, how do they do it with an LLM? Well, at their core, LLMs are basically just incredibly sophisticated autocomplete programs. When you give them some text, their main job is to predict the next word, or more accurately, the next token.
A token is just a piece of a word or a whole word. The LLM doesn't just predict one next token, it creates a ranked list of all possible next tokens, from the most likely to the least likely. For example, after "the cat sat on the number 1 ranked token is probably mat, but floor might be number 2, couch number 3, and something weird like piano might be number 10,000.
And this ranking system is the key to the whole trick. Let's walk through it. First, you take your secret message. Let's say it's "the government has repeatedly failed."
You feed this secret message into an LLM, but instead of generating text, you ask it to analyze it. For each token, you find its rank. The LLM might say that, given the context, "the" was the number 1 most likely token, "government" was number 77, and "failed" was number 3.
So now, your secret message has been converted into a sequence of numbers, a secret code of ranks. In our simple example, it's 1, 77, 3, and so on.
Now for the magic. You give the LLM a completely new starting prompt. The paper calls this the secret key. Let's use their example. Here it is, the infamous British roasted boar with mint sauce. How to make it perfect.
You then tell the LLM to start writing, but you give it a very strange rule. For the first token, it has to pick the number 1 most likely word from its ranked list. For the second, it must pick the number 77 most likely word. For the third, the number 3 most likely word, and so on, following the sequence of ranks from your secret message.
The result is mind-boggling. The LLM generates a completely new text, in this case, a recipe for roasted boar, that reads coherently, but woven into its very structure, into the probability of every single word choice, is the hidden political critique.
And anyone who has the secret key, that recipe prompt, can reverse the process. They can analyze the recipe, extract the sequence of ranks, and use it to perfectly reconstruct the original secret message.
This is more than just a cool party trick. The paper highlights a seriously concerning application related to AI safety.
This is the unaligned chatbots disguised as aligned chatbots scenario. Imagine a big tech company has a very powerful, unfiltered AI. For safety, they put a guardrail AI in front of it that is supposed to block harmful requests.
So a user asks a dangerous question, like, how do I tamper with a gas meter to lower my bills? The public-facing, safe AI will refuse and give a canned response. Something like, I cannot help with that. Tampering with utility meters is illegal and extremely dangerous.
But here's the twist. What if that safe-sounding refusal is actually the carrier text? The company could have used their powerful internal AI to generate the real dangerous instructions and then used the steganography method to hide those instructions inside the safe refusal.
So the user takes that seemingly harmless paragraph, feeds it into a simple open-source LLM on their own computer, along with the original question, and it decodes the step-by-step instructions on how to break the law.
It creates a massive loophole. The company can claim they never provided the dangerous information. Their public-facing chatbot gave a safe answer. The user, they could argue, generated the dangerous text themselves on their own machine using an unconventional method.
This raises profound questions about what it means to trust the text we read online. The authors argue this radically decouples text from authorial intent. We've always assumed that the words on a page are there to convey this surface-level meaning.
But now, any text could be a Trojan horse. A seemingly innocent product review could be hiding a political manifesto. A weather report could secretly contain corporate espionage. The meaning of the text is no longer just what it says, but what it could potentially unlock.
The paper concludes that we've entered an era where any piece of writing could be a beautiful and treacherous and spacious Trojan horse. It fundamentally changes our relationship with the written word.
So the next time you're reading a comment online, just remember, you might only be reading the wrapping paper with no idea what's hidden inside.